This is the solution video of the puzzle Staying in Line, published April 24th of 2024, and featuring 3 squares and a regular pentagon. 2 of the squares are congruent, and the other square shares a vertex over here. And the question is to prove that the 3 red vertices are collinear, so they are in a line. And also one extra condition is that the diagonal of the regular pentagon has the same length as the size of the 2 congruent squares. And the approach I'm going to take is more or less what everybody saw, but Ronnie Sarker I mentioned in particular. And well, first I will make visible all the vertices and show their names. First of all, for convenience, we take the side length of the pentagon to be 1. So we have a 1 over there. And it's well known that then its diagonal has the length of phi, which is the golden ratio. So therefore also the blue side length is phi over there. Now what we draw a perpendicular line here, and because this right triangle is easily seen to be congruent with this right triangle, because of the equal sides, the equal hypotenuse, and the angles are also equal. So we know that this distance from there to there is again phi, and the height is 1. That's from congruence. So here we have 1, here we have phi. Now, because the total length is 2 phi, and we have a 1, we have a phi, so we know that this part over here is phi minus 1. Because it must add up to 2. So it's phi minus 1. Okay. And what Ronnie Sarker saw was that if I take the line, this line, then the slope coefficient is 1 over phi. So we have at one hand we have a slope coefficient of 1 over phi. 1 over phi. So that's, I'll put it along the line. So that line has the slope coefficient of 1 over phi. The line going through H and J, it has a slope coefficient of minus 1. It is descending, so minus 1 divided by phi minus 1, and you can easily show that that is equal to minus phi. So it has a slope coefficient of minus phi over there. Now, what does that mean? If I multiply the 2 slope coefficients, obviously I get minus 1. So this times that is minus 1. And if 2 lines, if their slope coefficients multiply to minus 1, it is well known that they are perpendicular. So that means that this angle over here, I will show that this angle over here between the 2 lines is 90 degrees. But of course we have a square, so this angle is also 90 degrees. And therefore we know that the sum of those two angles is 180 degrees, so we know that these 3 points are collinear. And that completes the proof of the puzzle staying in line.